Okay, we are recording now. So I need to compile. So I need something like, I don't know, GCC. GCC enough? Do we have
Yeah,
any
GCC.
Cling
Just
specific
GCC.
things?
No, nope. Just GCC. Maybe
Okay.
libc, but I think that should be enough. Just GCC.
Racket Tower. I just remember I found a repo of a Brazilian guy adding pull request review support in Magit in Emacs. So that's something that I need to ask Magit and
Oh,
Victor
by
to
the way,
test.
if you can support the maggot guy, uh, Jonas Bernoulli,
Mm-hmm.
the guy is starving, literally.
Oh.
He's living with like $2,000 with his wife in Switzerland, so he's starving.
Oh.
Yeah, and he like there's a donation, so you can donate directly to him.
Okay, I'm gonna take
So
a look into that. So we need. Oh, you said libc as well, right? Well, but let's test with found libc first.
yeah, I don't think we need that. Maybe we
Okay,
don't.
so where the heck this thing is gonna live? So let's create a folder FFI. Is this a single file or we are talking multiple files?
It's a single file, yes.
Okay, so this is gonna be b plus
Why don't
3.c.
you? Yeah, I would call the folder utilities, maybe.
Okay, I'm
So
gonna
we just
change
dump.
the utilities. So here we go. Give me the magic. Okay, we need to give context. We didn't say what the heck we're gonna do. So today
Oh,
we're gonna
are you
do.
streaming? Are you
No,
recording?
I mean I'm recording this.
All right.
Today we're
Okay.
gonna do FFI with C in Racket because everybody is lazy and we're not gonna implement B plus 3 ourselves. That's
I
what we're
would
doing.
rather say nobody here is crazy enough, but lazy also works in this case.
It would be a very big false contribution for sure, but we are not in the mood for that.
One of the things that I got when I thought it was funny when I was searching this is that there is very little done on like B plus specifically. Like you find a few pieces of code that deal with like a a B tree,
B3.
like but a B plus that you have everything on the
And I gotta
leaves
say,
and then you have
B3
to
is not a
change the
binary tree. For if anyone is
yeah.
listening to this, B is not of binary. It's a completely different thing.
Yeah, so if like you can look for it, but the idea of using a B tree, a B plus tree, is that you have indexing in the intermediary nodes, and then you just access things on the nodes in the leaves, which will always be ordered. So it's a very efficient data structure, but it's very hard to implement. For example, just the removal of it is insanely complicated. Um, so yeah,
Yeah. Yeah,
but
and why do we
basically it's
need
a linked
this?
list.
Because of indexing. We're gonna use this. I still
Yeah,
don't
for
understand what's gonna be
clustering
in the
actually.
nodes, but whatever it is, I think it's gonna be rows, but whatever it is, we're gonna use this to index.
I mean, what do you say the nodes? Because there are the leaves and the intermediary nodes. There are two things.
I think this is a leaf in this case,
Yes,
and
which is
this
a
is
node
a
as well.
yeah, and this is an intermediary node or whatever.
Yeah. So the point is the intermediary nodes, like for example, the one that is on the first row, let's call the 3 and 5. You see,
Mhm.
that's just an intermediary node, and it doesn't hold any value on it
Mhm.
on
Mhm.
our design. Okay. So on this tree, we're not gonna hold the actual values. Who is going to hold the values uh, um, has to be the pagination. Okay, so a page, and
Okay.
then we're gonna
Okay.
access. Okay, I think I should maybe give a, overview of the entire process before we start
That would
diving
be
into
very
this.
helpful. That would be very
Okay,
helpful.
so can you go on my code on the GitHub?
Can you
I
send me
don't know
the
if you
link,
will.
please?
I
Any
I don't have it here. Just search
GitHub.
yeah, my name on GitHub.
Ba 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 ba
Uh,
ba.
Perplex there first.
Wait, is this gonna be the there's some weirdness in here. This should be in SML.
Oh no, it's F sharp actually.
Yes,
The
I know, but the name.
Oh no, right. Yeah, whatever. I just thought of the name like at some point and I never changed. So if you I had to change the project so it's actually using a Microsoft thing, so it has all this bullshit, but we don't
And
need it.
you're using C++ for some
Yeah,
gathering of
I
popularity.
because it only compiles with C++. That's why on the Microsoft thingy. So anyway, I just had to change slightly the code to suffice my needs,
Oh,
but
there's
it's
debugging.
yeah, this is on the original. So most of it is the same. There's just a few helper functions that I used. So go back there on the SRC. So from this, I generate a DLL that I import on the disk. Can you open the disk? I rewrote the conversion file. You can ignore the other. Yeah. I rewrote this file to look like the OCaml implementation, which is far better than what I had before. So
Wait,
basically,
our OCaml implementation?
yeah, man,
Oh
that was
wow!
golden.
Oh
That
wow!
was much better because when I started, I had no clue what I was doing, right? So I did once and then we did it again and then we did it much better. So I used that. Okay, so
Okay, I'm just so
go
glad
down,
that that was useful.
go down. There, that part. So you see that I'm loading. So that's how you load the FFI on F sharp. That's it.
Okay, so this is basic. Okay, so this is not in here because you're basically having this only locally, I
Yeah,
guess.
I have to generate. Yes. So
Okay.
essentially, you just mapped the functions in C with the extern, and then you should be able to map them, and that's it.
Okay.
So go down a little bit. So these are the functions we're gonna have to do. I don't have hopes that we are gonna finish all of them today because they're very
Okay. Build pages. I
hairy, as you can
imagine
see.
this is pagination.
Yeah,
Oh
but
no, this
basically,
is
let me
build
just
pagination.
explain. Yeah, let me explain the units because I implemented search, at least basic search already on mine with indexing. So go down,
Oh,
go all the way down. There is a
all
search
the way
function.
search.
So we're gonna have to do roughly something like this. I'm still thinking about this design, but for now, I think that's enough. So we're gonna basically have a function that will handle a search based on projection parameters. Remember that on the relational model we have on sorry. So can you Google um relational algebra on Wikipedia? That works. Algebra Wikipedia. It's on Wiki. Yeah, go down, set operators, selection and projection. So we call in SQL the projection is the select and the
And the selection is the where.
selection is the where
Yeah,
basically.
I remember that.
So that's basically the idea there. So go back to the
Okay, so this is
code.
a query. This for
Yeah,
us.
so to do a query, we have to implement both, right? To do we can either ignore the select part, which is just query like anything, right? So all the roles of this you are gonna query, right?
Yeah.
So you're not restricting the set. The where, which is the select, will restrict the query. So
Yeah.
the projection params is just doing the getting the fields you're going to project. Okay.
Yeah.
So for now, I am basically just I'm using it wrongly. It's not what it's supposed to do, but we can go with that. And then we have the key, which for now is just a key value, the pair I'm receiving there, as you see, key name and then the
Mhm.
key.
Mhm. Mhm.
So it should be ideally like a proper where, right? But for now, I'm just querying based on a key just to test.
Yeah, that makes
And
sense for
then
initial
and
case.
then what I basically do is that I mount the pagination. So I what's the pagination about, right? Do you agree you're gonna have the things on the disk, right?
Yeah.
That's what we do right now.
Yeah.
There are two ways to access it. The first way and the most intuitive one, and well, slow as well, it is you load a position A, like at the first offset, you load this object and you compare with whatever you're searching, right?
Yeah.
And then okay, it doesn't match, it doesn't. So you keep going, right?
Well, that's gonna be slow as
And
heck.
you always, by the way, have to go all the way to the end because not always, but most of the time, if 99% of the time I would say, you're going to have to go all the way to the end of the file because well, you don't know if there are more things that match this specific thing. Like for example, let's suppose you say it's a primary key that you need to search on equals to, let's say. So I want to know if the ID is equals to.
Yeah.
Like if the system knows it's a primary key, it's easy because it knows unicity, right? It can enforce unicity.
Yeah.
But let's imagine you're searching by something that is an index that is like 2 as well. But it's not a primary key and you don't know that.
Sure.
What will happen is, oh, hello, Nata. Um, what will happen is that you're going to have to go all the way to the end to have certainty that there is no other record in the entire thing that is 2 as well, that meets this requirement, right?
That's true. That's true.
So basically, we want to avoid that, but that should be the default case because if you fail to do this pagination building, you're gonna have to do that. How can we minimize this pain? Because think about this: if you have 1 petabyte on the disk, you're not gonna load 1 petabyte on memory, right? You
Yes.
probably don't have 1 petabyte of memory. So
Yes.
you should do like an operating system and load it in chunks. So that's where the problem starts. So we should define a structure called a page that will contain a list of binary that will contain these chunks. And these chunks will be many rows. So on my case, and I got inspired by SQL Server, it's 8K. So 8
8K
kilobytes,
lines? Oh,
8 kilobytes.
bytes. Okay. Kilobytes.
So if you have a row that is like 64 kilobytes, let's say, you could store 64 kilobytes, 8,000, right? Divided by 64, which, well, sorry, 64 bytes, I meant.
Oh, okay,
Divided
okay. And
by
now it
60,
makes
yeah,
sense.
otherwise it wouldn't meet,
Yeah,
yes.
it wouldn't
But
fit.
yes. So yeah, we have to handle that case as well, which is a pain in the ass. But anyway, um, okay, so that's it, and then we just load this chunk, and then we go building the indexing per page. Okay,
Okay,
so we can build the
stop.
indexing multiple
Stop.
ways.
Marinho, are you
Okay,
following as well? Because it's important for both of us to understand.
yeah. So far, I stopped on the pagination.
Yeah, yeah. Yeah, because if for some random reason my Gita is occupied next time, you and I are gonna be the folks with the knowledge. So we need to listen to the teacher.
Okay, that's
Okay.
fair.
The teacher.
Okay, go.
Uh, so basically, the idea of using pagination is that you can cope with having less memory, right?
Yes, yes,
Less RAM,
yes, of course.
less volatile memory. So that's basically the flow, but that's still not indexing because you can still access that to use it serially, right? You go load a page, search on this page, and then you go swap the page, search on the other page, and progress.
Question, teacher. Will the pages of that we are loading as chunks, will those things participate in the B plus 3?
Yes,
Wait, the
that's the
pages
whole magic.
themselves or the index of the pages?
So the page should have an index array that basically will point to the offsets in the map, which are the rows, right?
Yeah.
So the chunks will be arrays of arrays splitting the rows, right? That have the binaries inside of it. So that's why array of arrays. It's a byte array. So it's gonna have a byte array, something like that. Can you go up? I think I have the structure up there. Go up. Yeah, there.
Pagination.
You see pagination?
Yeah.
So pages is a page array, and then I have a tree, which is
Page.
just a pointer.
Okay, page
Yeah.
is an array of array of bytes.
Yeah, that's just to make it easier to access the indexes. And then I have the int array, which is basically um, the position, the logical position, and the physical position.
Wait, are you gonna use these to query in these?
Yes.
Oh,
So the int, for example, is the first int there on the tuple. It would be something like I don't know. You're searching two, right, on the query I was talking about.
yeah.
So the first one would be true, but the second would be, I don't know, 10, because that's the 10th value. You see the 10th
Mhm.
row.
Yeah, yeah, yeah.
So it would be in the 10th value inside this page or in another page. You see? But of course, ideally, you should just have the things that you have on this page, right? That's the purpose.
Okay.
Okay, so this build pages function is the nightmare. Let's go down this build pagination. I think it's easier. So okay, what we're gonna do is basically this. You're gonna instantiate something like a page based on a chunk, and then based out of this chunk, you are gonna build a tree to look at a portion of the tree, let's say, with the other function up there. So we'll now go up with this. There you see it's pages, which is an array, all this
Mm,
monstrosity.
mm, 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 mm.
So it is basically picking pages, like the amount of pages you can have loaded in memory at a time. So I just made like 64. So 64 times 8 KB. Um, yeah, max pages at once. You see there?
Oh, here.
So
Mhm,
that's
mhm.
the most you can have. And then it's basically gonna mount these pages, splitting whatever you can. Okay?
Wait. I think I got lost a little bit. So, uh, we are gonna build a bunch of pages. We're gonna build a bunch of pages. Can you
Mm-hmm.
explain or maybe repeat if I already did? How do you pick an entity NDF, and read it to
Right.
make pages?
So you're gonna read, like, think of the file as if it has 1 megabyte. Okay?
Sure,
And let's suppose you can load 512 KB at a time
sure,
on the memory.
sure.
So you're gonna load in two pieces, right? You're gonna load first the
Yes.
first half, which is 512, then the second.
And this
So what
file
you're
only contain rows.
yes, it will contain them in bytes, right?
Okay, that's okay.
So what you're gonna do is that you need to split them by the size of this entity, right?
Yes.
That's the line 123 there. Instances
123.
is
Yes, yes,
buffer with
yes.
array chunk by size, and then I get the instance size, and then I take based on the bound of this whatever the page can take. So until the like if it
Okay. Question,
surpasses,
question, question.
go on.
Uh, what do you do if the size of a row is not a multiple of the instance size?
No, I just ignore one page.
Okay.
One sorry, one slot, right? Because it will always fit. Well, not always, but most of the time it will fit. It will just not. I'll
Be
probably
optimal.
just have a gap on
Yes.
the end,
Yeah,
right?
it's called fragmentation.
Yeah. So you want to obviously diminish that because you're wasting space.
Yeah.
But basically uh, uh, and the other problem is also bad, which is your page is too big, which is funny because people think of fragmentation and they start adding columns, right? But as you add columns, you're basically increasing the values, the row size for the page, which is in some databases, not all of them, like SQLite, is just making it slower and slower because now you need more pages. So
That
anyway,
makes sense. That makes sense.
so that's totally well, that's why you need to read the docs. But um, okay,
Okay, but go on.
so now let me. I just want to give the base idea. Okay, we can go on the details later, but basically what I'm doing there is that to build the indexes, you need to iterate over this string of bytes, and you need to attribute an index. Okay,
Mhm.
so you're gonna have some parameter that you are looking at, which is that attribute to index. So I'm gonna try to find that, and then I deserialize this thing. This is really bad, by the way, because I'm deserializing everything. So this is not what I should do necessarily. But I just project one value that right now it's hard coded as a integer. Um, that will be a select function. So think of this: when you store a index in like a primary key, whatever, in Postgres, the primary key can be almost whatever, right? I think in Postgres, no, it cannot be whatever, but it can be most of the things like
Sure.
that are comparable, right? It needs to have the equality implemented for it, right? Otherwise, how it's going to compare, right?
Yeah.
Makes no sense.
Yeah.
So basically, I'm just using an integer for that. And then I build that tuple. So that tuple is going to be basically my index. Okay?
Mhm.
Uh, and then after I'm done with that, then I just build the indexes and then I attribute to this page and then I just iterate to the next page and so on.
Um.
And go up. I think it will make it easier looking at the four
Okay. Okay. I
steps.
just have one little question. I understand how you got the instances. You're basically doing, well, dividing up by the instance size. That makes total sense. Um. What my question is, attribute to index, because you're doing a map try find
It
on
would
it.
be something like, for example, in this on the example I was testing, it was like a table with two values. It was like name, which is a string, and age. And then age was the attribute to index. So it was like you would search, okay, search on this thing the age, and then it will give me the value. And then I say, okay, it's then a map of this value to this integer, which is the what is the I there? Let's
Uh,
just see if I got it. If you got it,
from what you said, I think it's gonna be the age.
it's the index of the map, right?
It is the index of the map, but you said that the age would be used as in the index as far as I
The
understood.
age would use as an
Yeah,
index.
you said there's a table with name and age, and then the
Okay.
age would be
Oh,
used.
age. Oh, okay. I was understanding age, like
No, 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 no,
okay.
not age. Age.
Yeah. So the age would be the value of the age is the value on on line 128,
Yes.
and then the I is the position that I read this column. So it's kind of the role ID, right?
Oh. Okay. Okay. I think I
So
understand.
that's it. And then what we do is that we build that, and then on the instances, I'm gonna have that on that position. And then if I consider it sequentially, I will have the I pointing to one of these values, right? Because if I concat all the pages, all the instances of all the pages, I do you agree I'm gonna have like all the tables, right? And then I'm gonna have the I, and then I can access which page I want. You see?
Yes. I think I see.
That's why my implementation is not done because I need to keep track of what is the bounds of this. But anyway, that's for later. That's not a problem right now. Okay,
Oh,
but
okay.
where's the tree coming from, right?
Yeah.
So
The
one
tree
wait, go down
tree. So we need to
there.
find
So there. So 146. You see there?
tree. Array
After I
fold.
build these pages of this chunk, I got I fold, creating a tree, inserting the key and the offset. What is the key and the offset? The value and the I.
Mhm. Mhm.
And then what I do is that I start with 0, which is the null pointer, basically. And then I build it, the tree, and then
Why
I
is the
split the
name
tree.
offset? Why is not index?
Because it's the physical, well, it's not really an offset, right? But it's the position on the disk. That's basically the idea.
Okay.
The If I multiply this value by the amount of the instance size, I should get the offset. So that's kind of
Yes.
wrong, the name.
Yes. Yes.
But
Yes.
anyway, go down, and then I was making a function that is the search ontological key because I don't like primary key, the name. But anyway, it's not done yet. Uh, and then on the search, all you have to do now is iterate over these many times. So you get the chunks. So in our case, it was two chunks of 512, right? In the
Yeah.
example I gave.
Yeah.
So you would have to split the total amount by that chunk size, and then you're gonna iterate that many times, and then you just load that chunk to the disk, build the pagination, get the tree, do the search of the tree, based on the parameter you have, which is line, let me see, yeah, it's line 178. So I tree find and get value, which is a function I had to modify.
Mhm.
And then I pass the last chunk red, blah, blah, tree, and the key and false. Yeah, see, yeah.
That's so
I mean,
wrong on so many levels. Depends.
Yeah.
Depends
I mean, I
even.
know that there will be no index on
Ah,
an array called -1, right? So
yeah, but
anyway,
this is so like C.
yeah. Oh man, once you use this, there's no way back.
Actually, if you believe in indexing from the end, it should be the beginning. Usually, -1 represents the last item in the array,
Well, I
so
mean,
it
in
could be
C,
an index. So
no, it could, but in C, usually minus negative values they have like
Oh,
semantic meaning.
I could also speed null there, right? And pattern match null. That doesn't matter.
Yeah, I think no would be better in this particular case, but it's just funny. This is just funny.
Yeah, anyway. And then I get the and then I access the page. And then right now I'm just getting the 0 because well, it's just the first page that I'm caring about to do this example. And then I access the position on that offset and then I deserialize again. That's why this is inefficient. I'm deserializing twice. And then I filter to see to get only the columns that were projected, so the attributes.
Okay, I think I got a rough idea. I think I'm gonna have a better understanding of this part once we implement it.
Yeah, but one thing that I have to say here, this is a very bad implementation.
No, yeah, you said you were deserializing
Uh,
twice. You're gonna fix that, but
no, not only that, like structurally it's bad because what I'm doing is kind of cheating. Because think of this, not cheating, I would say that, but what I'm doing is basically this: I am reading in chunks and then I'm comparing things based on the values. There are some problems associated with that. Like if I'm searching something that is like uh like we're gonna have to fix the comparison function the to see if the value is actually equal. It will have to multiplex all the types that have implemented equality, so we're gonna have to have that.
mhm.
um let's see. Oh, there was another thing that I had to say that was important. Can you go up, Lemus? I
Yes.
might recall. Go up. Oh, right. So do you agree that I'm reading um so the problem is I should have on the tree all the indexes at once, right? So
Yes.
basically, there are two implementations I could have done. I think the one I did, I wouldn't say it's bad. I think it's just a trade off, maybe. But what I did there is that I read I go cycling through the file, reading things in chunks, and then building the tree for this chunk, right? That's what I'm doing. Another option is to basically change somehow this deserialization so we don't deserialize, and then we build just a tree based on all the disk, and then you just have another entity that is like saved, persisted somewhere that has like some gaps that we just do the indexing based on that. Did you get it?
I don't think I got it, but I got a feeling that you're basically doing caching, doing that.
Kinda, yes. Because think of this, it's kind of still inefficient because I still have to go through all of it, right?
Yeah.
To get to know, like, if I'm doing a search, like for example, greater than 5. Well, how do I know if there's not something greater than 5 down on the last things on the disk? Well, I would just know when I load it.
Yeah.
If I have everything ordered on this structure, which is the using the ordering of the tree, I already have it for granted. I just know exactly where to get. So I would do the query on the tree, and then I get the offsets in a list, which would be a spacing on the leaves, which we can search already. The guy unfortunately implemented that. So we would get a span in the leaves, and then with that span, we would iterate over that, getting all the indexes that we want, and that's it.
But you only get that for free if you have this sort of caching mechanism for the primary key, right? If I want to do
Yeah,
anything or
for
any
not for
other
the primary key, but for an index, right?
an
For
index,
something.
yes. But if I don't have if what I'm asking is not the index, like greater than 10, but it's another field of the row, then you lose that, right?
Yeah.
Then you're screwed again.
Yes.
Okay. Okay, I think I see.
I mean, as far as my understanding goes, yes.
Okay. Okay, so we have two options. We can implement the pages mechanism, the pagination, or we can see if FFI works. I don't know if we're gonna
I
have time for
recommend
both.
starting with FFI.
Okay, let's go with that then. FFI. Okay, so let's
Uh,
just make a roadmap for people that didn't get it. So we need to re-implement sort of like this, which is kind of cheating because it's already kind of done. But Mageta
by the way,
said that
what
our
we're
way of
doing is a non-clustered index. By the way,
okay, we're gonna have to go to the definition in a bit. So we started doing this, Camo, and apparently I don't think Mageta no Nathan listened to this. So apparently Nathan, our Camo implementation was improved in comparison to Mageta, so he ported the OCaml to
yeah.
F sharp,
Oh, by the way, I
which is
discovered
funny.
a awesome thing in F sharp is that you can also type begin and end after a module declaration. So the errors goodbye to the errors of the you see module read equals begin.
Hmm.
So goodbye to the indentation problems with modules in F sharp.
Oh, okay, I didn't know that. Okay, that's cool.
I just can't run the formatter because Fantomas removes all of this because they're verbose.
You at least have a formatter. We didn't even have that for Racket.
Oh, I wish we didn't actually
Why?
because it sucks, man. It really sucks.
I don't know if it sucks. It's very it bothers me that we have two different multiple types of indentation because there are multiple Lisps. So when Marinho codes, it's basically closure style indentation and formatting. And when I do, it's something else because of other influences like Commander
No,
and
but
blah.
that's a different case.
Actually,
What I'm saying is that
actually,
the F sharp implementation, I don't like it because it removes like verbosity. So, for example, if you type in on Latin, which I think has semantical meaning, it basically just removes
Yeah,
it.
but that's just
Why?
stupid. That's why you
Yeah,
hate it.
yeah, I know, but that's why.
um,
The reason they gave is that it's harder to parse. Man, like that's
What
honestly
are
that's
you talking
bullshit.
about?
Yeah, that's bullshit for me.
how does removing information make it easier to parse?
Well, you have less
They
tokens.
no, I don't think it's on the token. It's I think they're talking because they modify the AST, right? The
Oh, okay. So removing the in required changing the AST. That's interesting. Wow,
But
that's a big deal.
but
oh
you're
they parse
removing
the AST.
information.
I don't know if they modify it, but they parse it.
Yeah, yeah, they
So
are
you're
removing
removing.
information. They are, and I already talked to Mageta about this. Like, it's a minor detail, but it reminds you of the semantics, and it should not be removed. It should be at least optional. And arguing that's harder to parse, it just sounds like laziness. Laziness, not Haskell laziness, just pure human laziness.
Oh, both are bad actually.
Depends on the
Uh,
situation. You can optimize with
yeah.
laziness.
Oh man, I'm just joking.
Just a side note, Lemos mentioned I do closure style indentation. That's not actually quite correct. I actually use the Tonsky's style of closure indentation specifically because it doesn't need to know about whether a symbol is a function or a macro. Like traditional styles of Lisp indentation actually need to know that, which means that suddenly the formatter needs to know what the code does, which kind of sucks for a Lisp because the code can be it can do whatever you want, right? It's a Lisp,
Yeah.
so
Yeah. Okay. Anyway, thanks for the clarification, Marinho. So let's go to FFI. We already have a roadmap. So we're gonna make we need two requirements. We need to implement do the FFI in order to have C stuff, and we also need to build pagination. And I think the pagination will be interesting, even though it's less interesting in FFI because I think I'm gonna understand a lot more things about the whole database stuff and pagination stuff like that after I try to read this through.
Oh my yeah.
We need a merge though, Marin.
oh right, right, right. I ran the code on my machine. It seems to be working fine. I'm just going over the actual code changes, which I mean, I was doing this with you, so I kind of already kind of know what it does.
Yeah, we are kind of cheating. Mageta should be the one reviewing, but well, well.
I should indeed. But will I?
C
Probably not.
mode. Do I have C mode? Simple C. I don't have C mode. Oh, oh, okay. So can
Um,
I package install?
By the way, um, I'm pretty sure I mentioned this at some point already, like in another occasion. But just FYI, Clang comes with an LSP for C and C++, and maybe Objective C as well. I'm not sure.
Oh, 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 yeah. About that. Mageta, I don't know if you read the random channel, but I sent a message
I
there
don't think
saying that
so.
I was looking at Hacker News, and the first job that opened when I opened the website in the Who is Hiring post was a job asking for Objective C slash Swift experience.
Well, that's not so. That's
Deb,
very
deb, deb,
believable.
deb, deb, deb.
But that's actually very believable.
Okay, so once we have the C file, which is this, I want to make the .so. So do you have this command already written for me, or are you just using you're just doing yourself?
Just a second, man. Like a problem at work.
Okay. Okay. While you do that, I'm gonna start looking into the. Let me know when you approve the PR, Marin.
Hey, I two files left to look at, so I'm halfway through one of
C
them.
files. Okay, FFI. That's gonna be really really interesting. How 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 fitting. They are not highlighting the C code.
I mean, the documentation system is optimized for Racket languages, right?
Yeah, but again laziness. I think there should whatever they're using to make the website, they should have like multiple types of highlighting.
And they do. It's just that in order for that to actually work, they would need to implement a parser. Like they would have to essentially implement a C front end for Racket, which sounds like a lot of work,
Man,
considering the
Emacs have this.
wildly.
Like, what are you talking?
No, I mean, I'm pretty sure, and I could be wrong about this, but I'm pretty sure that Racket's documentation system actually uses the hash length system to do the syntax highlighting.
Okay, Emacs is saying apparently that but this is a lie. Clearly a lie. Oh no, it is written C though. Okay. Okay, and it is being highlighted. My bad. Okay.
Ah, man, I hate how people make a big issue out of nothing, man.
Yeah, and be careful. We are recording.
Oh yeah.
But your sentence is from Mageta as well. Malok. Okay, I also need to clarify a thing because I'm 100% sure that the fact that we're not implementing ourselves the B plus tree again, it is because first because of the complexity and the time constraints, you're not that interested in implementing this, and because of the laziness as well, because this is a very classic thing that would exist in C anyway. And there's another thing that I think about it. I think that the balancing of the B plus, because B trees usually they have an operation of balance, right? So this is like 100% more easier to do with you have the pointer abstraction, right? Which we're not necessarily using in our project. We could if we want to implement it, and using pointers is a lot easier. Okay, so it's more than 1,000 lines. Yeah, so okay, so this is a lot of work. Yeah, a lot of work. Okay, so let's go to. Did I save the flake? Yes. Okay, so let's go Nix develop. Now I should have GCC. Yes, I do. So how do you compile to the .so? That's a very good question. Compiling .so C. It's been a while. Oh, here it is. Linker option dash R path, which tells the linker to add information in the executable where to find the runtime libraries like your SO file. I don't know, but that's not what I want actually. I don't want to compile it using it. I want to just make it. I just want to make it. Uh, I want to compile. So in C, yes. You need first to compile C with the fpic position independent code flag. Very interesting. This will generate an object file. Now you can take it and create an SO file. Okay. Thank you very much, sir. So we want utilities, and I want B plus tree, and this will generate a B plus tree as well. So let's see if this works. Okay, so my terminal I think got corrupted again. Let me open again this. Close this. Close. In function main. Is there a function main? Oops. Oh, there is. There is a function main. Interesting. Very interesting. Ignoring a bunch.
Oh, did it compile?
I think
Okay, so
that
do you
we
have the O?
should. I
Do
think that we should have.
so just use GCC dash shared.
Oh, it is. It
Ah,
is here.
yeah, just now compile GCC shared. Yeah, that.
There. And then we're gonna do utilities slash b plus tree, and this is gonna be something like b plus tree dot so. And we have an error. Interesting. Oh, I know why. Because this is not what it is supposed to be. Which means yes, we have a dot so now. How cool.
Just a sec.
I'm gonna update the git ignore. Actually, I'm gonna update the just file as well. I think that's gonna be useful. So b plus tree. Oops. So this is gonna be GCC. Yeah, there. Actually, not that. Yeah, that. The chili cheese. Then
Okay.
is everything all right?
Yeah, I guess it's just that I have to keep replying people scared things.
Are you scared?
No,
Okay,
not at all.
nice. Uh,
Fear is the mind killer.
utilities slash that, and we're gonna have that. Okay, then we're gonna go to the git ignore, and then we're gonna say something along the lines of utilities this dot o and lib b plus 3 dot so. Oops, there we go. So theoretically speaking, oops. Okay, another buffer bugged. Close this. And just b plus 3.
Uh,
Thank you very
Folks,
much.
I need to go to a call right now.
Oh, that's kind of sad.
Um,
But we know what to
but
do. We're gonna do FFI.
yeah.
Thank you,
Okay, so
teacher.
just try to do the following. See the functions I mapped there. Some of them I probably you don't have, but they're pretty intuitive what you should do. Yeah, there.
Some what?
Look in the DLL part. Yeah. Go up. Go
Here?
up. No, no, go up.
Go
Go
up.
up. There. Tree. This tree module. You see?
Yeah.
Just try to map this and call and see if it works.
Yeah, so this is exactly what the Racket documentation starts with.
Okay. So I'll go there. If I finish soon, I will show up.
Yeah. Best of luck.
Good good luck
See you,
extinguishing
folks.
a fire.
Ah, man.
Yeah.
I just want to set myself on fire at this point. Anyway.
So Magita.
See ya.
Okay, this to do is important. I should do this at some point.
By the way, the PR is approved.
The PR has been approved. So let's freaking go. Okay, so now we're gonna have the fun. Confirm merge. Nice. Okay, so git status. We have a bunch of things that we don't necessarily care about, so we're gonna do a git stash. Then git branch. I hope, yeah, we do have master. So let's go there. Let's pull origin master, and this is gonna be a new branch called FFI. I'm gonna say it's a B plus 3 FFI because maybe we're gonna have more FFI later. And then I'm gonna undo the pop. Thank you very much. Okay, now we can go to the documentation. How nice. How freaking nice. To use FFI, you must have in mind a particular library from which you want to have access to a function or a value, a particular symbol exported by the file, the C level type. Did Maget already did this for us? Yes, thank you very much. The library corresponds to the file with these suffixes, which is fine, and holy moly, why? But okay.
Because Apple.
Knowing the library's name and or the path is often the trickiest part of using FFI, which is kind of funny. Which is kind of funny. Sometimes when using a
Naming
library name, sorry.
yeah, naming things is hard.
Yeah. No, it's not naming them. It's knowing their name. They already have a name. It's worse. It's knowing their name. The library file can be located automatically, specifically on Unix. See FFI lib for advice. The FFI lib function gets a handle to a library to extract the exports of the library. It's simplest to use define FFI definer from unsafe define library. Okay, so I'm very concerned that the first thing the documentation is teaching us is something with unsafe in the name. That's kind of concerning.
I mean, we're calling C code. It's inherently unsafe to do that.
That's a bad argument because this is a particular case of FFI. And what he's talking about, it seems to be a general FFI library. So it's kind of meh. It's kind of meh. But oh well, he's focusing on C, so I guess Marinho has at least um, an okay argument to say the least. Uh, okay, so then we use something like that. So define cursors. So I'm assuming this is the name of the .so file.
No, but I mean, calling using an FFI is inherently unsafe because the whole point of an FFI is to implement things at a lower level than your language supports, right? Otherwise, why bother going outside the language at all?
I don't think that's inherently the semantics of FFI. I think if you have a program that you want to externalize in language X to language Y, you're gonna use FFI. I don't think that inherently means that you're doing low level stuff. Usually it
But
is because the low level stuff is already implemented in C, but I don't see
that's
why
the
you can't
thing.
do it in Haskell, for instance.
That's the thing. The canonical way to do FFI is to use the C ABI. So you must presume that the other side of the FFI is C.
No, no, no. In that particular case, yes, but my question is, can't you do FFI with other things that are not C?
But they pretend to be C in order to be called by FFI. That's the point I'm trying to make.
Okay, so they pretend. That's interesting. Uh, you have a really weird sense of fun. All of us have. What are you talking about? I have no idea what Nathan is talking about. Anyway, and weird. In this case, the weird is good, Nathan. The usual normie definition of fun is boring. So we are good. We're good to go. Anyway, so I'm assuming this is the name of the .so. I'm assuming that. And I'm assuming these are the functions that we want to grab from C. And we want to make those things callable by doing this. And that's it? Is that it, actually? At this point, our normal Racket binds to Racket functions, so they can be exported from the finding module called directly. Oh, that's really interesting. This is really easy. Okay, we're gonna try that. We're definitely gonna try that. So
Magic.
we need to add the library to the thing, or is this like embedded in Racket?
It's embedded in Racket.
Awesome. So let's do something like that.
I'm pretty sure you do have to require the FFI unsafe at the very least.
Yeah, yeah, that makes
That's
sense.
where FFI lib comes from. But yeah, it is
That totally
embedded
makes
in
sense. So
Racket.
where the heck this is gonna live? Are we gonna put the Racket code within the same folder as the C code? How cursed is that? Are we gonna go to hell because of that?
I mean, we could. I don't see why not. That's
B
kind of the thing about
plus.
the way. That's kind of the thing about how Racket does things. It's actually pretty liberal about your directory layout. Like it
Oh,
doesn't
but this is not
put
gonna work though,
why.
because I remember having some problems having files within folders and having them to call each other. This is the reason why we have everything spread in the root. I hate it from the beginning, but I couldn't make it work in the way that I wanted because I didn't want to spend too much time, like a bunch of time, reading Racket. Not this Racket.
With an R.
Writing language. Yeah, this. So this has I opened the repo of this, and they structured in within folders, and I tried to copy that, but I was too dumb and too lazy, and it was fairly complex in my opinion, so I didn't do it. B plus 3 Racket. Okay, now we are talking. Um, so later on we actually should make an issue about that. I'm very bothered by this uh, everything in the root. I'm very bothered by that. So do I have the things? I do seem to have the things. So let's change the mode. Let's put ling Racket. We already have those things. I'm gonna assume this is a path, so lib b plus 3. Um, and this is gonna be define b plus 3. Okay, that seems okay. Then next step is actually to use this define thingy to actually do the things. I actually have another question,
Yes.
which is window pointer, CP pointer. So this is a C pointer for a window. Do we need anything like that? Maybe we do.
That's just an alias for a pointer type, basically.
That's an alias for a pointer type. Let's actually copy these things. The reason why is because we're gonna forget them. So let's
Uh,
have
by
them
the
here.
way, by the way, Racket does have block comments. You could have used one.
Much easier to use the shortcut. I'm sorry. And this is how Emacs does the block commenting. So if you're telling me that they have block comments, so but I don't know if
Uh,
my
yeah,
shortcut does that.
like Lisps in general, they usually have the comments to the end of the line. But Racket in particular also has block comments that you can use.
Yes, I see. Um, okay. So let's think about that. So this is returning a window pointer. That's why he needs this alias. Are we gonna need anything like that? Because I think all our functions return, yeah, void, int. I think this should be fine. I think this, we
Probably,
don't need an alias. I think.
probably not.
I don't think we need an alias. Replace string, and we're gonna replace curses with b plus 3. Very nice. So the first function that we want is print leaves, which is interesting. And this is a function, and this is the return type of that. But in our case, this is void. So how will we manage that? How do we manage that? Do you just do underscore void?
Um, that might be it. Let me double check.
Interesting, interesting. So we have that. So which one do we need aside from those? Oh, you also need the parameters as well. Okay, that makes sense. So let's put insert. Then we have fun. We don't need the we have another void star there, which is interesting. Yeah. So this is going to be void. Then we need an integer. So this is probably an int and another integer, which is like that. Cool. Next up, find and print.
Yes,
Uh,
underscore void is in fact correct.
okay, that's good to know. So this is going to be void int bool, and the return is going to be void as well. And finally,
Actually, you can't use void as a function input, like for C functions,
oh, so how are we going to do
because
this thing?
that's a void pointer. It's not void. It's a pointer. It's a pointer to, or it's a pointer that we don't know what it points to basically, but it's a pointer. Let's see pointer types.
Oh, maybe we should make an alias for the pointer then.
You can do underscore pointer actually if you just need a void pointer.
Underscore pointer, you said.
Wait a moment. These pointers can have a arbitrary Racket object that attaches a type tag. The tag is ignored by built-in functionality. It's intended to be used by interfaces. False
So
value is converted to null. As a result type, the address referenced by an underscore pointer value must not refer to memory managed by the garbage collector. Makes sense. Um, okay, yeah, it's underscore pointer for void pointers. Yeah, but now all the functions that return voids because they mutate stuff and don't actually return stuff. Wait.
that's true.
Yeah, it just the insert actually returns a void pointer, not just void, so it should be underscore pointer. And then
That's true
find and
as
gets
well. And
value
this is
actually returns an int.
int. Yeah.
Yeah.
Okay, okay, this seems reasonable. This seems reasonable. There's another thing that I'm very concerned. Where is how we create a goddamn B tree? How is Magetta doing that? Because he's not importing any constructors per se. So how how is he doing that?
Magic. Or maybe he just
Oh,
isn't yet.
wait, is the insert returning a tree? Oh, it's returning a pointer. Oh, okay, so if you provide a new or something, you actually get. Oh, that's very. Oh, that sounds a little bit weird interface. Yeah, weird interface. I think this probably is new.
Yes, int pointer 0. Yeah, probably no.
So that means that he's creating the tree from scratch. Okay, so very interesting. Weird interface. Weird. So let's make a function to test this out. So this is gonna be a tree test. A tree test. And this is gonna. What is Magetta putting in there? Random values. Okay, so we're not gonna receive anything. And we're gonna do the following. So let's create. Let's do a let. Uh, oh fuck. I don't remember. Is Racket the one that we have the convention of using these, and closure is the one that mandatory?
Yeah, Racket, it's done by convention.
Okay, that's okay. So my
And
understanding
actually,
is that we're gonna do something along those those lines.
uh,
Of course, not like that. Uh, and I think this is gonna be new,
that's actually gonna be false.
false. That's weird.
No, it's
Uh,
not, because in Scheme, unlike Common Lisp, like in Common Lisp, new is treated as false and everything else is treated as true, right?
yeah.
And there's no like Boolean type specifically. By convention, you use the symbol T for true, and new is false. That just flat out. For Scheme, it's a bit different, and Racket is a descendant of Scheme, so it follows this tradition as well. For Scheme, there is a proper Boolean type with values true and false. And false is the only value that if recognizes as false, and every other value is considered true.
Okay.
So that's why false is what actually becomes the null pointer when it
Oh, this
crosses
is not
the
closure,
FFI
man.
boundary.
This is not freaking closure. I am so confused. Uh, we need this. Yeah,
Yes,
okay.
you do.
Oops. What the? Wrong shortcut, yes. So this is gonna be 3, 2, star. And I don't want to be very long, so we can just, oops, we can just do something like 3, 3, passing 2, and which values do we want to put? 2, 11, 3, 12. 2, 11, 3, 12. Okay, after that, we're gonna call print leaves, and we're gonna pass 3, 3, I believe. Yes,
Um,
that should be kind of it.
the way you wrote the FFI declaration for print leaves, it takes no arguments.
Uh, takes no
It should take a
argument.
pointer, right?
What I was thinking. This is a pointer. Thank you, Marin. Okay, so now we can just go to main. We can just go to main. Let me just put this. I'm gonna. I don't know. Well, what is the best way to do this? I guess the best way is just commenting all of that. We need to import the thingy. Oh, we need to
The
export
thingy.
as well. That also makes sense. So provide tree test. Oops. Where are we importing stuff? Here. Very, very interesting. So my understanding is that we're gonna do Racket Tower DB B plus 3.
Actually, you have to put slash utilities between the RacketowerDB and the B+3, I think.
What? Sorry?
I'm
Where?
pretty sure you have to put RacketowerDB slash utilities slash B+3
Why?
because it's in the utilities directory.
No, it's not.
Oh, right, it's not. I forgot. You moved it outside. Okay, makes sense. That's fair.
Okay. And we're gonna just call. 3. You sounded so sad saying that. Sorry if I said something bad.
Yeah.
Well, yeah, I am sad. I'm sorry. Just build. This is not gonna work first try. There's no way. What? Are you joking?
It it printed nothing apparently. Why? Oh
Oh,
wait.
it worked! Holy
Ah, it actually.
moly! Okay, I don't know if this makes actual sense. But we have 1, 2, 3. We actually do have 1, 2, 3. I have no idea what the other numbers are then. Probably the other numbers are like the dots in here or something.
Or something.
Is there a function like is there anything printing related? Print 74. Oh, print
Print
tree. Print
leaves.
tree is very
Print string.
interesting. Print tree is very, very interesting. Uh, let's actually acquire print tree as well because why the heck not? So
Let's
print,
print both just for fun.
yeah, that's okay. So we're gonna first print the tree. So let's print the tree, passing tree. Then let's do that. The warnings. I still need to figure out that. Okay, so whatever the print tree does, it just adds a pipe at the end, which is not very useful.
Huh.
Not very useful. So I don't think we have any other prints. These are the declarations, right? So we only have 2 print functions. And probably Magetta tried both as we did and discovered that the print tree is not worth it. That's what he did. Uh, so that's it, man. That's really very surprising. Easy, easy, easy. So now we have FFI. We can use C functions to do our stuff. This
Apparently,
took
yeah.
way less time than I expected. So I guess that means that we need to start thinking about pagination. Yeah, I think that needs to be the case. So where the heck this pagination is gonna live? This is not AST stuff. So the struct of the pagination we're not gonna live there. That's for sure. Uh, let's think about it. Let's think about it. So my initial instinct is to make a file called pagination dot racket. Pagination dot
That
racket.
could work. That could work.
And then in here we're gonna have the definitions of the structs as we did in here, and we're gonna start with the page. And I think there was two definitions, right? That we care conversion. We care about a page, and we care about pagination. I'm inclined to not call this pagination though. I'm inclined to call this pages or something like that because pagination doesn't sound like. What do you mean by that? What do you mean by that? Pager,
I
maybe a
mean,
pager. Hmm. Go on.
Uh,
Oh man, we don't have to serialize this. I need to, we're not gonna use the define deserializable for the first time ever. That's very interesting. Uh, okay, so let's put lang racket in here. So what else do we need actually? It's been a long time since I did like this like from the ground up stuff.
type
Uh,
translation, basically.
no, not try. No. It's
Translating.
not. We're not translating. Not about translating Mageta's code. It's like how again? What do I need to make the structs and stuff like that? Oh, we are using struct update for some reason. We have Racket generic as well, threading,
Racket generic.
which for some
The
random
Racket
reason is not
generic.
in the base.
That's because like first Racket existed, and then Clojure existed and had threading in it, and then Racket was like, oh, that's actually a good idea. Let's copy it. And then some Racket user made a threading library inspired by Clojure. That's why it's a library and not built-in.
I see. I see.
Uh,
Um,
Though to be fair, in principle, Clojure's threading macros could also be written as a library. They just aren't because Rich Hickey found that to be useful, so he added it to core.
um, we don't have methods for this thing because we're gonna.
Well, first
Doesn't
of
make
all, it's not
sense to make.
first of all, it's not defined struct, it's just struct.
Yeah, I don't remember the syntax. That's the problem with having your own macros. You forget, you forgot, you start to forget the base, the basics.
Um,
That. So it's just a struct. Thank you, Marinho. I actually want to do the guard of these, but we're not gonna have any interfaces yet because I don't think it makes sense. Right? I don't think it makes sense. Which means
yeah,
that we're gonna have only
and
functions used for these things.
so pages, page, right, page. Page is
Page is basically the chunk. It's basically the chunk. And then we're gonna have something that I want to call a pager, which is something that has pages within it. So pages
wait. Real quick, go back to the page declaration. Like
here.
the that's a record type, isn't it? Like
Uh, oh man, I think it is, but I'm always confused which languages use the keyword type for actual definition of types and for type aliases. I think this is actually defining
um
it.
no, that's not really what I'm asking about. So what I'm asking is instances and indexes are like two fields of a thing, right? They are
Yes.
not.
That's true. That's true.
Ah, okay.
In the pager we have a tree, a b plus. No, I'm gonna put tree because we know this is already in the realm of implementation, so we know it's gonna be a b plus. And we also need an amount already read. Amount, amount already read is kind of long. It's kind of long. Hmm. I'm gonna put amount read. I think that's enough.
That's
Uh,
fair.
okay, so now let's do the guards. Let's actually do the guards. So, is this the macro that you made?
It is. It is.
Okay, so in that particular case, we need to import something, I think.
We are already importing it from YouTube. It's on line 7.
Okay, cool. So now, I don't remember exactly how to use it. Let me go down to see use cases. Oh, so this is how you use it. Okay. So the first thing is this, and then we're gonna put the predicate there, and then the
And then
next
the
thing is gonna
indexes.
be another predicate here. Predicate. And
Uh,
we're gonna return the values. We're gonna return the values. So values instances and indexes.
you're missing
And
an S in instances.
that's true. Uh, Here we have pages. We're gonna have a tree, which is gonna be really interesting. How the heck we're gonna check that? I have absolutely no idea. An amount read. and this is also another predicate. And then in here,
The amount read is probably an integer, right?
yeah, that's the easiest one. I already also forgot.
It's exact non-negative integer.
Oh, it's already there. Okay, exact non-negative integer.
You
And
gotta love Racket numeric predicates. They're so specifically worded.
yeah, that's nice. That's nice. We don't have any doubt about what's happening. That's cool. Okay, now the hard ones. Now the hard ones. How are we gonna do the array of arrays, for instance? Let me remove some of the stuff. So the only thing that we are using here. We are only using that, and we don't need anything else right now, actually. Cool, 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 cool. So how we gonna do an array of arrays? I have in memory, in recent memory, that we did something very fancy. Yeah, something like this.
You may, since this is meant for indexing a database, it has to be performant, right? I
Yeah, we,
wouldn't
we can't
recommend
use
using,
lists. We can't use lists.
no. You probably want to use a vector then.
Okay, so can I? This is just a question. I don't know if this makes sense, but would I be able to do something like vector off?
I think you can.
Okay, so we want a
Vector
vector
off.
off of a vector off again, and I don't actually remember. Go up of bytes. Okay, byte.
Oh, in that case, the letter vector of could be a byte array, a byte string instead.
Do we have any gains doing that?
We do actually. We use up 8 times less memory.
Okay, so let's go with that. So byte. Um,
Byte question mark.
no, but we want a byte array. How can I specify that?
It's bytes question mark.
Like that?
Yes.
Okay. And the indexes, for now he's using just that, but we're gonna do exactly the same. So this is also needs to be performant. This also needs to be performant. So vector of um,
Uh, Let me
values,
double.
uh, uh, no,
It's not
exact
values.
non-tech. It's not values,
It's
right?
not. It's not values because values is for like returning
Oh, it's
multiple values
cons
from the range.
actually, right?
It's const. Yeah,
Yeah, I
I'm pretty
remember
sure
that.
it's const.
Remember that. Uh, do can those integers be negative? That's a very good question. I don't think they can because they are positions. So
Yeah, it's. By the way, the vector of const has to be const slash c because it's the const contract, not the actual constructor function.
that makes sense.
And yeah, that's exactly.
Okay. So now there's the question. How are we gonna make this a vector of page?
Yes, yeah, that's correct, I think. Because
Uh,
page question mark is generated by the struct declaration and we
yeah,
can just use it.
yeah. This is dynamically generated. Now the big one, the remaining one. How are we gonna enforce this to be a tree? That's very interesting.
Ah, I mean,
It is a void pointer. So how the heck are we gonna say that? Like we don't have functions that
intertime
return a struct pointer like the example in the documentation. So
type layout.
that's quite interesting.
Uh, ah, that is a good question actually. Ah.
Yeah, that's a I was waiting for Mari for you to say, yeah, I don't know if I know how to do that.
I never actually had to use the Racket FFI, so I'm not sure.
Oh, he's not saving the tree actually. The tree is just a label. He's actually saving a native int, which I don't remember. native int. So the type of machine size signed integer number is annotated with a unit of measure. The unit of measure is erased in compile code, and when values of this type are analyzed using reflection, the type is representatively equivalent to int pointer. To int
Which is probably
pointer.
a pointer-sized integer.
Yeah. So okay, now we have more information. Now we do have more information. So with that in mind, what should we put in here? That's quite funny. Like my instinct is saying to put this because we put false in here.
Actually, false is translated to the null pointer when you pass it to the function, so
Oh, so there's an extra trick going on there. I think I see.
um, but that's just the thing. I'm not sure how a pointer is represented like on the Racket side things.
Okay, so let's ask.
Wonder if there's a pointer question mark that we can use. That would be very convenient.
That would be extra convenient, my friend.
There we go. That's our man. That's what we want.
Wow, that wasn't expected. FFI. Do I need to put parentheses? I think so. Unsafe.
You don't. I mean, you only need it if you plan to restrict what you're importing. Otherwise, don't bother with parentheses.
No, but it's not gonna be. Well, yeah, it's not gonna be. Oh, it is now. I'm doing the intention. Okay. Very interesting. Very, very interesting. So, what else can we do? We found because now we like how much time we have already in 1 hour and a half. Like we could spend 30 extra minutes trying to already do some stuff because I think Magetta was also just as myself imagining that FFI would take debugging and stupid error messages and stuff like that, but apparently it didn't.
Apparently not.
Apparently this is like just a piece of cake. Thank you very much.
Yeah, thank
So,
you, Racket, and thank you, Chase Scheme, actually, because I'm not sure if you're aware, but Racket actually uses Chase Scheme as its backend.
okay, I didn't know that. I didn't know that. I'm very glad. I was very surprised when he said, "Oh, I picked our implementation in OCaml because it was better." Man, that made me feel proud. Like I'm not joking. Very, very unexpected. Um, yeah, I remember this. I remember this. Sort by the first and map the second. Yeah, that was a long time ago, and that was very frustrating. Although the parsing was a lot better than in Racket. But maybe we didn't pick the best of the best in the Racket side. So there's that too.
Yeah, like my first instinct when I'm trying to parse something non-trivial is to reach for a PEG library. I already mentioned how I like PEG for parsing, so I'm not going to elaborate on that because I already did it.
Yeah. No, but that's fine. That's fine. Because when we did Nokemo, I think we picked main here, right? So main here. Okemo. Okemo. And as far as I can tell, this is like a very well-known parsing library for Okemo. So we picked the best of the best at the time that we were aware, at least. In Racket, we just searched for a parser in the search and picked the one that seemed more like parser generators. Um, okay, something that we could do in this remaining time, if you want, is try to reorganize the project. Try to put folders and stuff like that.
Uh,
Do you want to do that?
I mean, we could do it, but is it interesting to record? Like, it sounds kind of boring to watch.
Yeah, that's true. Another thing that I just noticed, I named the branch B plus tree FFI, and we are doing already pagination on it. So, yeah, I don't know if we, I don't know, maybe I should rename the branch. How do I rename the branch? It's a very cool question. So B probably, rename. Okay, so pagination FFI. Oh no, rename branch. So I think this is asking which branch I want to rename, right? I'm gonna put
All
cat
right, so my
2.
internet decided to sneeze.
No, I'm gonna actually do the opposite. FFI and pagination. And done. Okay, thank you very much, Magit Powers. I appreciate that. In that particular case, then, I'm gonna commit. So let's commit. Um, okay, so which things we want to put?
Definitely not the main.racket because since you commented out the print tree function that you made for testing, and if you commit the change to main.racket, it's actually gonna break.
That's true. That's true. I'm not gonna commit to main. So the first thing I believe that we should do, the first thing is to put utilities and the flake and the just, and this is gonna be a commit of add b plus tree.c and gcc support in the project. So that's one thing that we should do. Next up, I should have committed this as well with that. Okay. So update git ignore. Okay.
Oh, and fun fact, we don't actually need to update the Geek package definition because it's already using the GNU build system, which includes GCC, so we're covered on that.
Nice, 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 nice. Okay, so then I'm gonna put the b plus 3. So and FFI for b plus 3 Racket. Uh, um, um,
Library,
b plus 3 library for Racket.
Libre,
And
Libre.
finally,
You wrote
add.
Libre in the commit message.
Oh, now it's already there. Well, I could git amend, but I'm not in the mood for that. Add initial structs for pagination. And I'm gonna push that right there. Okay, so theoretically speaking, if I go to our repo, actually the question is, will Mageta be impressed? That's the question.
I don't know. He might be.
So FFI and pagination, create pull request. Create pull request. Oh yeah, Libre. I'm sorry. I'm sorry for that. I
It
think
happens.
I think we can finish for today then. We had a conversation with Mageta about to have a rough idea of what we're gonna be doing, which is important
Merge the
because
PR.
yeah, we merged the PR. We got an idea of what we're gonna be doing in the next pagination slash B plus 3 phases of the project. We did FFI in Racket, and we already converted some of the stuff of the pagination stuff to Racket, and we already added the guards, which is rather convenient. So I think next time what we're going to be doing is actually going through these functions. And something that I want us to do is to not try to be one. We don't want to be pedantically mimicking what is being done here. If we see something in the implementation level that we can improve upon, we should do that. So for instance,
I
this is
agree.
serializing twice. We're not going to be doing that.
I agree.
We're not gonna be doing that. And again, if we can also find improvements in terms of like, oh, this for loop could be replaced with something else to be, I don't know, easier, more performance, whatever, we also should be aware of that. But I think we are good to go. I think we are kind of good to go. So I'm gonna finish the recording now.